So, welcome back. This is the third lesson in Module 1, and it's the second video. In the first video, I showed you guys how to graph a linear system of equations and solve it. Okay, and we also talked about what it meant to solve too. Okay, so I'll do a couple more here. We'll do example 3 and maybe also example 4 as well, just for some practice. Okay, so let's see what we can come up with here. So again, to solve this system, we need to get both of these in a form that's easy for us to graph. That is slope-intercept form. So I'll write over here 3x plus y equals -3. And again, for slope-intercept form, we want it to be y equals mx plus b in that form. Or we could also have it as y equals b plus mx. Either one of those is okay. This provides us with, again, the slope and the y-intercept, or the slope and the y-intercept of our line, which makes it then easy to graph. So in this situation right here, what should we do to both sides to get the y by itself? We should subtract 3x from both sides. And so we'll have -3 minus 3x. Okay, if you don't like having the x at the end like that, if you want to rewrite it so that it looks like this, you can always change this to add a -3x, and then we can flip those around and say -3x plus -3, like that. Okay, either way, what's our m and what's our b? What's the slope and what's the y-intercept? Pause the video and answer that question. So the slope is -3, and the y-intercept is -3 as well. Okay. Remember that a slope is more helpful to write it as a fraction, so we'll make it -3 over 1. And then, of course, then our b, we don't need to have it as a fraction. So let's go ahead and graph that. So we'll start with our y-intercept there of -3. And we'll graph using our slope there of -3 over 1. So down 1, 2, 3, and over 1. Again, remember that the slope is rise, so we're going to go down 3 and run of +1, so right 1. And instead of going down 3 and right 1, because I'm kind of out of space down here, I can go up 3 and then left 1 from my points, and then up 3 and then left 1, and now I'm kind of again out of space, so I'll just connect these dots using my pencil here. Okay, let's go ahead and graph this one too. -2x plus y equals, 2. Again, let's get this y by itself. What would I need to do to this equation to get the y by itself? Add 2x to both sides. 2 plus 2x, those are not like terms, so we just write 2 plus 2x. Again, this one already has addition, so we can flip around that order very easy. I'll put that 2 over 1 to make the slope a fraction for us. So our b here is 2 over 1, and our slope is, our b is 2, and our slope is 2 over 1. Let's plot these. So 2, and then 2 over 1 is our slope. So again, rise is 2, run is 1. So up to right 1, put a point. Up to right 1, oop, we ran out of space. So instead of going up to right 1, we'll go down to left 1, and aha, there's our point of intersection. Down to left 1, down to left 1, down to left 1. And we'll connect those dots. And so what's our solution? Well, where do the lines intersect? What coordinates? -1, 0. Okay, and so we can verify then that it does work. So we'll, -1, 0 is our solution, so we'll plug it into this equation here. 3 times -1 is -3, plus 0, so it's just 0 equals -3, so check it works. And then -2 times, -1. So again, plug the -1 for the x, plug the 0 in for the y. -2 times -1 is 2, and so check, that one works too. Could the point 1,4 be a solution to the system? Again, we kind of already understand that's going to be impossible, right? We already found the one point of intersection that there is when we have two lines, right? Two lines will only intersect in one point, and so this 1,4 cannot be a solution because we already found the solution. Okay, so we already know that's the case. But you can again say that if you want to as a justification. You can also just plug 1,4 into one of the equations. So I'll plug it into this one right here, first one. And we can see, 1,4, so that should be a 4 there. 3 times 1 is 3. 3 plus 4 is 7. No, it's not going to work. Okay, so no, 1, 4 does not solve 3x plus y equals negative 3. So it cannot be a solution to the system. Okay, number 4. Sketch the graphs of the linear system on a coordinate plane. So we have 2x minus 3y equals 18, 2x plus y equals 2. So again, same situation here. We're going to solve both of these for x. Solve for y. So we'll subtract 2x from both sides to start getting that y by itself. We'll have a negative 3y left over here. And then we'll divide everything by negative 3 to get rid of that negative 3 times y. So 18 divided by negative 3 is negative 6. Negative 2 divided by negative 3 is positive 2/3 x. So there's our y-intercept, and there's our slope. Okay, and then 2x plus y equals 2. So subtract 2x from both sides. 2x minus 2x is going to cancel out, so we're left with just y. And then 2 minus 2x is just 2 minus 2x. Whoops, positive 2 minus 2x. There you go. So again, our slope is going to be negative 2 over 1, and our y-intercept will be 2. So 2, and then negative 2 right 1, down 2 right 1, down 2 right 1. Again, the rise is negative 2, the run is positive 1. That negative only goes with the 2 or the 1, not both. Okay, it only goes with one of them, so that's why I made it go with the 2. So down to right 1, down to right 1. I can go up to left 1 as well. So that graph that, and we'll graph this one now. So negative 6 is the y-intercept. And the slope is 2/3. So up to right 3, and there's a point of intersection. Up to right 3, up to right 3, up to, oh, we're out of space. And so we connect the dots this way. And we connect the dots this way. Okay, and voila, there's our solution. At the coordinates, 3, negative 4. Okay, verify it's a solution to this equation, so we'll plug the 3 in for the x and the negative 4 in for the y. Okay, let's see. 2 times 3 is 6. Negative 3 times negative 4 is 12. Positive 12. And yes, 6 plus 12 is 18, so check. And we'll try here as well. Again, putting 3 in for the x, and negative 4 in for the y. 2 times 3 is 6. Wait a minute. Something's messed up here. Let's see. 2x plus y equals 2, minus 2x, positive 2, down 2, right 1. Minus 2x divided by negative 3, positive 2/3, negative 6, yes. 3, negative 4, yes. Oh, plus negative 4, there we go. I forgot the plus. Okay. 2 times 3 is 6, plus negative 4 equals 2, and check that's right. Okay, and of course, same kind of argument from before, 3, negative 1, it's not going to work. We already know what the solution is, okay? But that's not the greatest, justification. Let's just go ahead and plug it in here to one of our equations. So that's going to be 6 plus negative 1, which is 5, which does not equal the 2 that we were looking for there. So no, 3, negative 1 is not a solution to 2x plus y equals 2. Okay, so there we go. And yeah, we will stop there. I don't think we need to see more of these same kind of examples and stuff like that. So we'll stop from there. All right, thanks guys. Have a good day.